Good evening, everybody, and I hereby welcome you to the Atal's Faculty Development Program. And today is the third day, and we have very exciting sessions planned for you. So, our first session will be about the role of artificial intelligence and big data in smart transportation, which will be conducted by Mr. Sagar Reddy ji. Let me tell you something about Mr. Sagar. We are in, he is a highly skilled engineer specializing in core areas of network connectivity and embedded systems. His expertise spans through Wi Fi, where he has a deep proficiency in wireless network architecture, security, performance, and optimization. He is also specialized in MAC, the Media Access Control Layer, and ESE, that is Embedded System Engineering, focusing on the design and development of firmware and hardware that power connected devices. In short, Mr. Sagar translates complex wireless communication into robust, low level system solutions. And now, I would like to hand the stage over to Mr. Sagar to take the session forward. Over to you, sir.
Uh, yes, good evening. Please let me know whether my video and audio is both are clear or not.
Yes, sir. All clear.
Okay, okay. Okay. One second, I'll just set it up. So I will be having on my video on till I start my screen share. Okay. After that, I will switch off the camera. Is that fine, right?
Yes, sir. That is fine.
Sure, sure. Okay. So thank you one and all, like HOD, teaching, non-teaching staff, and all the department heads, and as well as students for giving me this opportunity as a part of this 6 day session. So I will just feel my gratitude to start this session. So I will just start sharing my screen, and I will start introduction also. Please let me know anyone whether my screen is visible or not.
Yes, sir, it is visible.
Yes, yes. Okay, fine. I will stop video and go with full screen. Please let me know whether this PowerPoint is okay for you. Is this fine, my everyone?
Yes.
Fine, nice. So uh, today I'm just going to explain the real-time scenario and everything. Before that, I just want to introduce myself. Myself, Sagar Reddy Guvala. I have total nearly 6+ industry experience, and also I have experience into training the students and also giving project deployments. Where I started my career with emphasis. After that, I worked for Siemens Technology. After that, I worked for Dell US, and from here as a remote. Now continuing with the current Eurofins. So meanwhile, I was worked into full stack development, where it is integrated with instruments and the sensors. When I was working with Siemens, right, it is like IoT based only, that particular project where the factories automation will be there. That factories automation, we will think of like temperature sensor, humidity sensors, object detection, OpenCV, everything. It will be involved. In that project, I worked. And the current applications, when I was working with Dell, it is also maintaining the logistics and transport operations. And the current application which now I am working into, Dell is previous, Siemens is that too previous. The current, I was working with healthcare. It is optimizing the instruments and the healthcare systems which are integrated with our full stack applications. This is what my experience. I hope all these three are covered, right? So we can start now. And meanwhile, I founded Margi Labs as a part of the passion to deliver some products or whatever it may be that comes to me as a part of opportunity, along with my side hustle. It's like a side hustle I started, correct? So let's start. So today's motto is to understand how the industry is evolving into autonomous vehicles, smart traffic control systems, and also fleet optimization. What is that fleet optimization? It is the kind of managing the logistics associated with multiple devices for the vehicles, where it will be having the optimal, transportation, which is almost with logistics only. So I will give, practical also, where the data is stored and everything. So when comes to market capitalization, so before that I just tell you the motto how we will go. So I will explain you how multiple sectors are involved in as a part of AI and big data in smart transportation, and also along with that how we can able to implement smart transportation, and how what are the technologies that are involved in smart transportation, and also what are the job opportunities that we can able to grab from electronics to computer science, everything step by step. And also what are the challenges we might face because of autonomous or automation. That is also one of the thing, ethically and also cyber ethically, cyber security wise and also ethically wise in human way. So what are the things that come into the picture which need to be solved by the future engineers, that you need to understand. So this and all I will try to cover, right? Along with the big thank you note at the end. Is this clear, right? The motto for you all. Okay. So yeah. If I ask you anything like, are you able to clear or is this clear? Anyone can respond by unmuting the mic. No issues at all. Okay. So let's start. So as per the market, surveying and all, so it will be almost by 2027 itself, because in the next 2 years itself it will be almost increasing by 285 billion dollars. Now you see it's 87,000 crores where Google is coming to invest a data center in our Visakhapatnam, as we know already. It will be 870 billion. Now the global market by 2027 for only smart transportation will be just as a starting point by 285 billion dollars. So 80% of the companies will be investing. For example, take few of the examples, like I will show you as a part of this. uh, Take DHL. As we know, there are three people who started that, and there is Fastln. This is also where I got one of the company, and also we have few of the companies. It's an international brands, right? Fastel and DHL. So talk about this. These are the good companies which is already having good market share, correct? So it will be starting from there because it is having international shipping. Next FedEx. I think FedEx will be there next. I was involved into FedEx project also when I was working with Emphasis. FedEx use a Java Spring Boot for backend. So if we start like this, there are multinational companies which they first start, implementing it. So 70% of the companies will invest into that for transportation and the smooth, transportation, to reduce the cost and time. How? So to reducing cost and time, how it will be there? You are just investing into AI, right? Some some of the thoughts that might come, you are investing into software. Again, by recruiting some of the future engineers or the AI engineers, how it will become cost effective? I will come to that picture. So that will reduce the congestion also. So using maintaining the real time traffic analysis. So there will be a projection which I just got some, few of the articles. The market projection from 2024, it will be $131 billion. So if it is converted into INR, normally 131 means 1,31,000 crores into 83 or 87 as the per the current rate. Okay. Then by 2033 it will be projected to expected by 424 billion, correct? And by 2047, India's growth as per the current statistics, which is 6.5 GDP, then it will be expected to reach $30 trillion, which will be the first or second largest economy by that time. If the development continuously grown like this. So As a part of that, first we need to take care of traffic management. So if you see Hyderabad or Bangalore, what is the situation currently? The first situation currently we are facing is unplanned development. That unplanned development will comes with drainages, and also managing the lakes or the rivers contaminated area, and also the water flowing. For example, if you are covered with the whole, the whole city that is covered with concrete, right? Then where the water will be sinking into the soil? Nowhere. Even the drainages below, the flooring will be concrete only. Then there is nowhere that water will be sinking. If you go to villages, whatever the water drop that comes, immediately that will sink. If that is exceeding its capacity to sink, right, then it will be there for 1 or 2 days. After that, again it will sink. The thing is here, first one, sinking water will not be there here. Apart from that, the roads which are like two-way, four line or six line, that is not able to catch up the vehicles, because there are millions of migrants that is coming to the cities. Because of that, in the higher peak days like morning and evening, on the Monday to Friday weekdays, it will be higher traffic. For these, again, the maintenance of the roads and autonomous navigation will be difficult when we are having these infrastructure issues. Definitely. So I can say the infrastructure is developing, but future focused infrastructure is not yet developed. And even the roads which we have will be like temporary. If something comes for continuously for 7 days rain, right, that the whole road will be vanished. So this type of infrastructure and all, it will be difficult in Indian roads to make this. That is the biggest challenge. Because the roadways or whatever it may be in the US, if you see, right, so that is having a thing, right, they might be laying concrete on top of the tar both. Even the rain will come for the continuously 1 month, millions of centimeters of rain, it will not affect the road. From infrastructure perspective to how we are collecting the data, whether sensors are working perfectly or not, this and all comes to picture when comes to implementation of autonomous vehicles, fleet optimization and everything, along with smart, smart drivers, which will be AI drivers. It's a blueprint, but that will run the algorithm. First, the first point which we need to take care here is how we store the data. So that's where the picture comes into. For example, I have the sensor which will detect the motion detection sensor, which will be object detection. I have one more sensor which will detect the climate and temperature of the current situation, wherever, in whichever the location you are. The next one that comes into picture, like geographical location, GPS sensors, whatever that comes, one by one by one, that should have large amounts of data. For every second, for every millisecond, you need to capture the data continuously. That is the first problem. That data, how we are integrating and storing it. So can anyone tell, for example, if you able to calculate the latitude and longitude of the current, vehicle, how it will be storing in the database? Can anyone tell that latitude and longitude, how it will be stored in the database? Or even it captured an image. In that particular image, it will be having red or green signal. Accordingly, it will optimize that particular algorithm based on the red or green signal, whether it should move it or not. Now think about it. Every second it will take one picture, and it will analyze it immediately, and it will process it immediately, and it see what exactly it is there in the image. That is a red or green signal. That is green for the straight, or green for the right, or green for the left. Whether it is red or green, that should analyze correct first. For every second, it should analyze the millions of data. Correct. So now tell me how the image will be stored in the database, and how I will come to the database next, or how the sensor navigation, which will be latitude and longitude, stored in the database. Can anyone tell? Any CSC or AI people? how it will be stored in images. It's an interactive session. Sometimes I will ask questions also, no issues at all. If you don't know, I will explain in live. I will do live code also for that. That is the intent of this session. It's not like I'm just explaining you the concept. Okay. So whatever I can able to explain you in the meantime, I will explain you. Not at all an issue. So now tell me, anyone can speak up voluntarily, no issues.
Sir, good evening, sir. Image
Yes.
can be represented as a numerical array, sir. It can be converted into binary values, zeros and ones.
Mhm. Okay. Anyone apart from your name?
My name is Aparna, sir.
Aparna,
Yes, sir.
good. That is good. Apart from Aparna, anyone? I will show you the live concept for that. No issues. Because this concept you will not learn anywhere. Okay. Okay. So let's take an image. Okay. So now the thing is, as we know, I hope this session is recording. This will be, you know, you know, in future you can able to see the same. Correct. So as we know, we all are CSC or AI students. Correct. Let's start this. I will help you to understand this, because this will be the practical thing, right? This image is not good. One second, I will take another image. This is also not clear. Okay, so how we can able to get this? Select this in the browser and select the image. Here the image tag in the HTML, that you can able to get it. Okay, PNG image. Okay, no issues, that you can able to save it. Okay, so now as we know, in the first semester of your graduation, that will be BE correct? So we have the ASCII table. ASCII table is the core principle, where it is having all the, all the keyboard inputs. For example, zero, correct? Zero's value is zero only. If there is a space, that value will be 16. There is a plus, that value will be 43. One second, guys. Sorry, guys. So I think here all the faculty members are assembled, right? If I am not wrong. Sorry if I pronounced as a students, ma'am. Anyone can speak up.
Yes, sir. Yes, sir. All are
Uh,
faculty.
okay, ma'am. No issues. So don't take it wrong. As a part of my training sessions, I just pronounced it as wrongly, correct? So can we continue? Are we good to go, right?
Yes, sir.
Yeah. So because as a part of daily training sessions and all, I pronounce it the same way. It's my bad. No issues. So okay. So here there is a space, that is the decimal 32. There is an at the rate where we enter the email, that will be at the rate, that is 64, as we know. So now this is good. Okay. So in keyboard, whatever the keys that we have, everything will be there. Here the decimal value will be the number, hexadecimal value will be on the power of 8s. So now I will take an image. For example, in my system, I have one image, or even there is a QR code, for example. So here that is a QR code, a PNG, portable network graphics format. So I will show you, there is a tool. So where I can able to convert IMG to base 64. I will explain the base 64 also. I think there is a website which will help us, which will be base 64 Guru. I will upload this file. Go to downloads. QR code. So now if I'm encoding it to base 64, this will be the original string. So basically everything will become as a string format when it is going to process. Correct? As we already know. If before it is going to process, everything will be converted into base 64. So now let it be. Let's save it as base 64 file. Okay, .txt. Now go there. It is 1 kilobyte. It is saying it's 1 kilobyte. Now the same txt file which I am storing is it's also 1 kilobytes, but actual size is 758. See, it's 560 bytes, correct? The 560 bytes is, you know, wrapped up into 1 kilobyte because 560 bytes I cannot allocate it. That I will show you, no issues. So its dimension is 580 580, which will be the square, and its size is 560 bytes. But why this base 60 file is increased its size? Because I increased the many spaces here. That also will count. So I will just put as it is, correct? Now I will save it. Now this text document and everything took 748 bytes to store. So now we will calculate how it is coming. Because without data nothing will be possible. Data will be raw data which cannot be understandable by anyone, only computer can understand. But now I will just copy this. It will be stored in the database this way. Now I can reverse this, reverse engineering. I will do reverse engineering for this. So it will be like base 64 to img as a reverse, correct? I will go back, means I will reverse it back. I think by base 64 guru, this website is better. I will just copy this. Correct. If I decode this, then see the image came. The decoded image came. So now, if you see, okay, so let it be. You don't know because you might confuse. Okay, with this it might get back. It will get. So can I remove one of these characters here? If you see the change of the image, see, cannot be displayed. It cannot be interpreted. I will do Control Z, or I will copy paste it. It will be decoded back. I will just remove the last three characters. See, it cannot be because it cannot able to interpret because this is the byte code. This is the byte code which will called as base 64. This byte code can able to understand by only our computer processing, but not our, but not we, because computer has having a registers in ECE perspective. If I say DLD, digital logic design perspective, we have flip flops and registers. So whenever we change some values, right, every time it will be shifting some values from register R1 to R2. This way it will calculate the result. The same way these characters will be calculated. Now we will come back to picture. These characters will be calculated with the help of these values. Now comes will come to here. As we already remember, small a starts with 97, capital A starts with 65, and the numbers will come in 30s plus or something, which I don't remember, but it will be like, yeah, 48. Hexa is 30, 48 will be starting number, and it ends with 57. So in HTML also, whenever we adding some validations, like it should be in the form of number only, then we will give ASCII code. Correct? ASCII code greater than or equal to 48 and less than or equal to 57. Correct? It will be accepting only numbers. Other number, PAN number will be the varchar, that is fine. Other number, mobile number, it will be accepting only zeros and ones. So now if you see here, every character I, V, B, O, I, A, B, C, D, F, G, H, I, which is the seventh character. So it will be 104. So every character, zero will be 40, 48, correct? I think 48, yes. So every character, even slash, even space, every character is having some value. For example, 104 plus 650, 65 plus for 34, there will be number of values. For example, this value is calculated as now 650 bytes, correct? For example, because image size is 6050 bytes, correct? If you go there and calculate again the image size, 650, 560, okay, it's reverse, 560 bytes. I will zoom it, no issues. 560 bytes. Now tell me, as we already know from childhood, we are using memory cards and everything. Now we have 1 byte. The next one will be 1024 bytes. Why 1024 also we can understand easily. Again 1024 kilobytes, which will be megabyte. Again 1024 megabytes. Gigabytes again 1024 gigabytes, terabyte again 1024 TB. I think 1 petabyte or yetabyte. Don't remember exactly. Yetabyte. Then it will comes to zettabyte also. Okay, let it be. So now as we know everything will be calculated in zeros. Now 1 byte equal to 8 bits, as we know definitely. So now we have 1 2 3 4. Again give some space, 1 2 3 4. So now there are 8 bits in a byte. So now it is taking 560 bytes, means 560 exponentially. If we have 560 into 1 byte, correct, that will be almost 560 into 8 bits, correct. That's how it will be calculated. So let it be. This calculation, put it aside mathematically, we don't want. But here, now for example, just put int age. Int is Java variable, declaration, or even C variable declaration. That's fine. Even C sharp, these three will be using the same: Java, C, C sharp. We will use the same. In Python, we will just put age. In JavaScript, we'll just put where or let. Correct? So now these are the data types. Leave it aside. Now age equal to 27. Now the next year it will increment to 1. So now how I can store the 21 value? Because here also everything, every ASCII value will having some numerical value. Correct? So now here, as a part of the computer understanding, it will be zeros and ones. So first zero will become 1, then only we will get 1. If the first zero is also not 1, then we will not get 1 at all. So that's where it's introduced 2 powers only, because if you give 3 power, if I put just 3 power 0, it will become 1, that's fine. But if I put 3 power 1, it will become 3. Then where is 2? 2 is missing. Correct. So I cannot go 3 power, 4 power, 5 power. I can go with the 2 power only. Because if I go with 2 power, then 1 will be there, 2 will be there, 3 will also be there. How? So it will definitely 2 power 1 equal to 2. Then 2 power 2 equal to 4. Then 2 power 3 equal to 8. So now if you see whether you are getting 1 to 10 or not, 2 power 0 equal to 1, we got 1. Okay, at any point of time, if you want 1, we already have the 1. Now 2 power 1 equal to 2, at any point we have the 2. Now at any point 2 plus 1, we have the 3. Now at any point 2 power 2, we have the 4. So 4 is also there. Now at any point we have 4 plus 1, 5. Now at any point 4 plus 2, 6 is already there. Correct? So now again at any point 5 plus 2, 7 is already there. No need to think about it. Now again at any point 2 power 3, 8 is also already there. 8 plus 1, 9 is already there. Now 9 plus 1, 10 is already there. Now 2 power 4 will become 16. Now it is beyond the limit. So we already reached 1 to 10. If nothing is there, 0 will come. So now see all the possible combination of the digits already achieved. No more to discuss here, because here we already achieved 1 to 10. So now definitely 3 power or 4 power is not required. So that's where computer is designed for zeros and ones only. Now how these are matched? As we already know, 2 power 0 is 1, then is the 2 power 1 is the first position. This is 2, this is the 3, fourth position. 8421421 code. It will be there in the DLD also, I think, which is already applied. And 16 32 64 128, nothing apart from this. So now when we are storing this age equal to 27, it will get the nearest value as we already know, 16 plus 8, 16 plus 8, which will be 24. So now, yeah. So when we are adding some first value into our registers, all our flip flops will transport that particular values internally in the embedded code. So this embedded people and all will be maintaining this, but internally how it is happening, whenever we give age equal to 27, 16 plus 8, 24 will be achieved. Means 16th place it will be 1 and 8th place it will be 1. Now 24 is achieved. Then what is the nearest value we need to achieve? That will be 2 plus 1, which is 3. Now it will be 2, it will be 1. So now 27 came. 27 is achieved. Again we added plus 1. This plus 1 now we want to do. So now this possibility again it will erase this 2, because we want to 4. 2 plus 1 is already there as a 3. Now we want 4, it will be incremented. Now this 1 will be getting to the left shift, and it will be 0, and again it will be 0. This shifting the bits will come as, I think, this you know unary binary operators, which will be having left shift and right shift. The shifting and all internally registers will take care of it. So don't go into hardware. But so now this image, we will come back to the image. So whatever the image that is coming, the base value we can able to store in a byte is 256 as a value. So that is why we cannot store more than 256 in a single byte. But we cannot store 256, we can store 255 only. Why? Because 0 whole number is also included. Now if you see, when we are working with IP address in our system, can I open command prompt and see? If I see IP config of my computer, so if you see here, my IP address v4 address is 192.168.1.1. It is the IPv6 address. When Geo came, is the number of devices connected. Now IPv6 is also activated. So now if you see subnet mask, so the greatest value which we can store is 255 only, because 0 is also included. 0 to 255 is nothing but a byte. Correct. So now if I have this small I, capital B, capital V, it will almost come. These three values will almost come to 150 equal to. Again, the next three characters will be getting 300. So now if it is 300, I need to allocate 2 bytes. Definitely, because the second byte will also be allocated. How it will come? Both bytes will be attached one after another. Like the next will come 256, 512, 1024. So that's where we cannot break the byte as a 2 powers. That is why it's not in thousands, it will be in 2 powers only. What is the nearest to 1000? They made it round it off to 1024, which is 1024, 1024. That is why we cannot break the byte. So that is where it is not round off to 1000. In my childhood doubt it is, till I joined computer science. After that I got to know, when I am preparing for GATE, our graduate aptitude test, I just got to know this. Before that I don't know whether we can round it off 1000. So now that's where every byte will be allocated side by side, and this value will be exponentially grown in the form of 2 power. So that is where all the values will be calculated to sum of, like now, 850 star 1024. I think it's byte, right? 256. That's how This value will be calculated some numerical, and that particular image will be sorted. But again, here one more scenario. Now the latitude and longitudes we want to store, correct? For example, these autonomous vehicles, it will transfer the data in the form of latitudes and longitudes. For example, 17 degrees, some 6 digits value will be there here, like this. And 77 degrees, some 6 digit value. This everything 1 7, this double codes, everything will be again processed in the form of bytes and will be stored in multiple databases. Even if you see video, that will be in the form of 12,080 720 pixel, or else 2460 something will be with 12,840 and 4096. It will be also in the form of this only. So now this 4096 we will call as 4K, as we know in YouTube also. So now this and all how it will came, because, so I think as per my perspective, there are the particles which are resided each other. For example, when we go to TTD Tirumala Tirupati Devasthanam, as we already know, there are screens which is having some vehicle, and there is having some screen and displaying something, right? I think in Mada streets, there are vehicles displaying. There we can see light emitting diodes. I already seen many times, because there are seen light emitting diodes which will be scattered horizontally in having very large space. So if there is a TV which is scattered having very large space, right? Those are the particles, or the binary light emitting particles, which is sending that data in the form of signals up and down, correct? So that is sending, because there are very less particles. So now this data will be transferred in optical fiber in up and down signals, correct? But here these scattered light particles are having more distance, means, so it is having less quality picture, because those particles occupying less space, which will be 360 or 480 pixel. 360 or 480 pixel, this is the one. Even that will comes to the images. For example, in the traffic signal, we have the proper image 1280 720 pixel clear image. We can see the clear image and clear number plate of the vehicle. Again, if you don't see the clear image, for example, this is the clear image. For example, this image we are seeing now here, if I am getting the 8 like this is the 8. If I'm not able to see it properly, I cannot able to understand it, because it is having more particles. Again, if that particular 8 will be darker line, which is understandable, there are more particles residing together, and it will increase the quality. That's where dimensions also will change based on the light emitting particles which is displayed on the screen. Because of that, this dimension will change. Now this dimension will comes to 1280, for example 720. Again, that will become 4096 star. Okay, 2080, for example. So again, it will be having some dark, those are light emitting particles will be having one after another with less, less space. Then our video quality also increases. So finally this will be also stored in the form of zeros and ones. That's where, as we think, this data will be stored. Now for this, I will just go to the next slide. So when comes to AI, yeah. So when comes to AI implementation in the smart transfer, transportation, the first thing which we want to observe is whether it is properly, whether it is properly implemented computer vision. So the computer vision is a concept where it is seeing the images or the videos, mostly images, because when a vehicle is moving on the road, it will observe the traffic lights, and it will also observe the vehicle movements before and after, which is having many sensors and storing that particular data. Computer vision will help us to understand the image optimization and image recognition. Then it comes to reinforcement learning. So the reinforcement learning will optimize the algorithm to make understand the previous route and the current routes and learning based on the previous data also. Now natural language processing will be activated. For example, there is a vehicle that is having, if you are observe something to give some command as a voice command, this voice will be translated into multiple languages internally. Natural language processing, NLP programmers will be there to process this data into multilingual, multilingual query. Now it will be doing predictive analysis for maintenance scheduling. So we want to schedule the maintenance on the what, even for every vehicle there might be maintenance, like tire from wheel to engine, everything will be scheduled as per the kilometer range and all. That data will be also stored. So this analysis will be there based on the vehicle to vehicle. So now the current generation is going on as per the, for example, now I booked the ticket of Comitla from Nellore to Bangalore. So now I will get the sheet of the data where driver will get the ticket and the ticket number and the person details with Aadhaar number. In the next 5 years, what it will be happening with these four in the AI? The first one will be, there might be a scenario when you are entering the bus, there might be a camera which will absorb your image and it will capture your image with the help of computer vision. Then it might say you natural language, it might say you, are you Sagar Govala? We can say yes Sagar. Then it will understand your and your voice if it is already registered, and this will be the face recognition. So this is the first step in transportation of the buses. For example, when comes to logistics, it will be there when they are traveling it, right? It might be the scenario when it is approaching the traffic signal, it will be decreasing the speed. So for example, there is a U-turn or there is a junction in nearby 100 meters, it will start reducing the time, because there will be a junction, it is observed that the junction signals, and also within 100 meters there will be a turning point. Then our vehicle, which will be getting signals from our computer vision and the AML model, which will predict within 100 meters there is a junction which will be having multiple turns. Then it will get the command that it will be reducing its speed. So now this will automatically happen with the help of AI. So now it's already might be there in China, because China is 30 years ahead from the India. There is a reason for that. So now in India, what we see from the last 60 years till 2014, what happened we know. As a person, we already know. The thing is, what happened from 1991, Dr. Manmohan Singh has decided financial, bill that has been passed. Before that, due to colonization in India from many rulers, privatization and private companies has not been established. There is a strict bill for that. From 1991 reformation, it's a great change to India. That's happened. Afterwards, only development happened. But real development happening from 2014, as we know, that is the different story. Now here, there actually what's happened, we are in the stage of just implementing AI or the digital transformation from the last 5 6 years only. Before that, we stabilized our country, that became make in India and making semiconductors devices and all, which will be a feature for the embedded and the VLSI engineers. Okay, so now software is growing, but the software jobs in the future will be, if you understand the AI and you can leverage the AI, there will be not like jobs will be gone. But the thing is, jobs will be increased in the sectors like automation, smart automation, like vehicle, along with mobility, automated motor vehicles, and remotely you are controlling from somewhere. That might be work from home job also you will get. This and all major industry will be transport, shift here. Finally, I will tell the job opportunity also. But when it comes to here, step by step, whenever I am explaining this concept, I will also include the job opportunities for the future engineers. For example, computer vision, I will be the developer where I can able to develop some algorithms to detect the image optimization, and also to detect some, something which will be long lasting forever. For example, if I am hired by a company to develop some computer vision for this, initially we had a large project. For example, DHL or Blue Dot, any name we can call, or FedEx, is implementing this autonomous logistics implementation. So now what they want a team where the team can able to build a web application first, to showcase that web application in the web, and also they need some mobile application developers where that need to be showcased in the Android and iOS app for all the users. The first user will be the truck driver or the truck driver monitoring engineer. Okay, then there are the web developers who can develop the HTML, CSS and the website. And there are also iOS and Android developers. If it is a cross platform, they can go with Flutter. So these technologies comes into the picture first step. So that is where even AI comes, something is need to be introduced, then definitely application development person or application development resources will be the first. So now these people need to think in such a way, if any new solution we want to implement, how we need to think. That logical thinking ability they will try to get by getting first examination and all, as we know, aptitude and reasoning. So that reasoning will get the spontaneous reaction, aptitude or arithmetical will get the calculation mind, whether how we can able to approach a problem, whether we go it or not. So this and all comes. So this computer vision engineers will try to create some algorithms. So now basically we are using Python, correct? So Python, that's where systems are heating up. Python is very slow, it depends on C++ compilers. Since it depends on C++ compilers, it is very slow. That is where all the AI systems, NVIDIA graphics, they're implementing GPUs and GPUs, because Python is having multiple libraries, say multilingual. Basically, it's having multiple libraries depending on easily we can able to get. If you want to implement linear algebra algorithm, which will be linear sequence of the data, even for some examples like uh, what I can say is trading. If you see trading, candles, red candle, green candle, okay, so there are multiple candles. So how it is getting populated? So there are linear series of distributions of data which is having multiple algorithms. So this A and ML engineers will get the predictive analysis in the automation industry, and also in the market capital sales industry, and also understanding future prediction analysis, how it will happen from temperature to, you know a sales history of the products. For example, Dell and HP are the competitors of the laptops. Now Dell is getting the more market. When I was working with Dell, I see market capitalization is less than HP only. But now Dell is introduced one laptop. That my laptop is also that one only currently. That is Dell Latitude 5410. From there onwards, Dell laptops are very harder than ever. Even though if I blow it on the ground, right, it will not easily crack it. So that's where market this predictive analysis, A and ML engineers will help us to build it. But it is not like in the college, if you are learning just Python code and will just understand the basics of the linear algebra like definition, it is not required for the industry. What industry is expecting for the computer vision or natural language processing. These natural language processing engineers can able to, if I give one script, right, they can able to easily make that script into multiple languages. They need to build an algorithm on that. Then it will be, then this person will be hired by DHL or the Samsung or the Dell or the Apple AI Siri or whatever it may be, which is involved as the voice enhancement devices. Correct. So this will be the jobs that comes into the picture when comes to AI in transportation and big data. So the big data engineers will also be there. When we starts with volume, there will be billions of data in the form of volumes, daily locations, everything that will be stored. Velocity, how fast you can able to grab the data, how fast you can able to transfer the data from multiple systems to store and get back it. So that's where it's very important that whether we are getting it clearly on time or not. Whether here also security issue also comes. So we will discuss this at the end. Now variety. So now variety will comes to different type of the sensors or the things which will comes to the wearable devices. These wearable devices will comes into the category of variety. Wearable devices means we can able to move it further from one place to another place without connecting it, like laptop, even mobile phone, our Wi-Fi camera, GPS sensor which will be attached at that particular point of time. We no need to have installation setup. This all variety and veracity, data quality from multiple sources. For example, it is getting computer vision and trying to analyze that road. In the middle of the road there is a left turn. If the data is, if data is modified in between, then instead of left turn, if it is analyzed as right turn, it will be very danger. Then it will take right turn on the immediate step. Then immediately truck will become, it will be prone to accident. Correct. So the value will be the outcome of this particular AI transportation and big data. Big data is to transform the data from multiple sources and making it optimized way. For example, I want to create a dashboard by reading the millions of GPS tracking vehicles. Even if you see Uber and Rapido, there are multiple users simultaneously happening. There are multiple values of the GPS, that will be latitude, longitude, which will be storing at the same time, and that will be real time, that is showing, that is moving. That particular Rapido user is moving, that particular Uber user is moving because of big data. And this particular Rapido user, whether that mobile application which they install, it is asking for location permission. The GPS sensors in our mobile will be activated when you allow using app or allow every time. Again, real time it will be storing the data and getting back as a part of veracity, and it will be correct source. If it is not correct, sometimes it will be hanged, and sometimes it will be getting the wrong data, it will be having in another location. Correct. This all should be processed perfectly. First, if you see vehicle sensors, this vehicle sensors, it will collect the data and it will be stored in a cloud. So basically in our system, if you're installing MySQL, RDBMS or MongoDB, NoSQL, which is documentation file format, it will be stored in the form of key value pairs. Again, that key value pairs will be zeros and ones only. So now everything is moving to cloud, because for example, now we are associated with JN2H, for example, JN2 Hyderabad. Now, whenever they release the result at 10 a.m. on that same day, nobody will able to see the result. Everyone is having server timeout 504, 500 internal server error. Why? Because if you are using the casual system or the on premises, I can say, for example, in college there is a server room, they're connected with some nodes. That nodes will be Dell EMC or the HP or any other Google EMC servers also, that is attached with some IP address, static IP address, that will be serving. That is fine. So now we cannot increase or decrease the capacity or the node automatically. We need to buy the same day. That is not possible. But cloud will get able to scalability of increasing vertically or decreasing, like, and also increasing horizontally. Horizontal scaling and vertical scaling. It will be help us here to transform, the request per second. So now on the same day there will be high traffic, because results are released just now 10 a.m. Nobody will able to get the result except the people who is having internet in their home, which is having high bandwidth of 100 mbps or 200 mbps. Others bandwidth will not be able to cover to get in the less time. Why? Because cloud storages will solve the problem here. We have the Azure, Microsoft Azure, AWS cloud, Google, you know Google cloud platform, we will call it as GCP as a short form. For any working professional, we will spell it like that. Correct. So now, for example, I am building an application for mobile application. Take about Instagram. In Instagram, every second there might be, in the worldwide, I can say 10 lakh users logging in, or 10 lakh users seeing the same reel. Correct. So the cloud storage should be, there is a system which is having some 32 GB or 64 GB RAM. and there will be a processor which is having octa core or the quad core or octa core, that will be having the capacity which can able to get only 10,000 request per second, RU units we will call. If I want to increase them, then I want to increase another node which is horizontal. If you want to increase in the same system, I want to increasing the processing power which will be quad core to octa core to hexa core, which will be 16, let it be. And I want to increase the RAM capacity to 32 GB to 64 GB, correct, which will be vertical scaling in the same system and horizontal scaling by attaching the new nodes. So this new nodes will be routing the roads from system 1. It will be already occupied 10,000 requests. Now it will balance the load. It will load balance, and it will from the 10,000 one request will come to the next node. This will be attaching the nodes. Now this automatically take care of scaling and up and down whenever that is required. It will take the rent for particular one day or the monthly rent for those particular critical days. So that's where cloud will be help us to increase or decreasing the capacity of the servers. So these servers are hosted in data centers. So now Google is coming to Vizag. Now Vizag will be getting almost our South Indian data, and the Singapore, Malaysia, what are the eastern countries towards India will be all, because why they will go with coastal areas, because internet is in the optical fiber only, as we already know. Go to submarine cable map. If you go to submarine cable map, why Geo is getting the cheaper internet also you can understand. Somebody already knows it, but as per my knowledge, I am also sharing this. See, if we go to India, there will be 3 to 4 points. Definitely here, definitely we can guess Tata Communications is one, and another Geo Telecommunications is two from the Mumbai. Okay, one is Tata Communications and one other one is Geo Communications. So that's where Geo business started. Geo laid their own lines in the South African and Eastern countries. That's where they became monopoly by reducing profit and making monopoly in the market. So before that, Indian government and maintaining the telecommunication along with Tata Communications, correct, and everyone is buying the internet. So I think on the surface, all the towers will get the radio frequency signals. Again, from radio frequency signals, it will be transferred in the optical fiber in the form of electronic signal pulses, which will be zeros and ones, up and down and up and down. Because if I download this application, for example, it's a progressive web app. If I download this application, it will be some 100 kilobytes. These kilobytes of this abstracted data. Oh, where it is? Okay, I will continue here. Will go here. Yeah, this abstracted data will be stored in the form of bytes only. Everything, for example, I downloaded 100 MB. My internet balance will be having that 100 MB. Then only it will activate. It will be able to communicate. Otherwise, no internet, because we don't have internet balance. Our 1.5 GB is exhausted today, so that will reduce to 4 MB or the 500 kilobytes something. It will be there. So that's where it started. So now every data will be transferred in the form of this. Now if you see that data center is coming near to our Visakhapatnam. So now this data center will laid some lines from here. Definitely when data center comes here, there will be the new lines that will be laid. They're also planning to lay off optical fiber, which will be communicated with Malaysia and these all the regions, so that till Indonesia they can able to store all the artificial intelligence data, or the data that is coming in the future in the next 10 years or the next 20 years. They can able to store, which will be 1 GB of data storage, which will be largest in the Asia, I think. in the same place, as it will be divided into three parts in the Vizag itself. So now internet will be in the optical fiber cable only in the sea, that will be communicated in sea, because in sea we cannot able to build the construct the towers. So that is already there as a part of the cable. So now everything will be stored as a form of data center here. I will just continue from here. Yeah, and it will analysis the traffic analysis for the vehicle movement, and based on the data on the previous and the current data, it will analyze and it will able to train the models. Again, to train the models, there are the people which will give some input data every day, whatever the new data that is producing and storing in data center, they will use the data and they will train their particular model based on the existing data, so that in future they can able to predict the same pattern that comes, which will be reinforcement learning, and it will optimize the routes. For example, now at morning 6, not 6, it will be evening 6. Morning will be 9 a.m. to 10:30 or 11 a.m. It will optimize the routes based on the traffic and based on every day the same amount of people will be going on the roads. Again, every day at evening 6 p.m., the same amount traffic will be there. Based on the time, based on the signal, what it is going, it will be mapping the data and it is trying to understand whether we have alternate routes for this, whether how much time it will take. Route optimization will be there based on the algorithm which is already having. And finally, it will be having consistent feedbacks by the managers who are analyzing it based on the daily basis. Accordingly, they will able to optimize this using this technology. Till this point, are you clear, faculty, my dear faculty members, ma'ams, and everyone? So whatever the knowledge I have, I just trying to explain in my perspective. Is it good till now, ma'am? Anyone can respond, ma'am?
Yes.
Okay, okay, madam. So I will continue. So now the approaches here will be in the three categories. So for example, processing the data. So approach will be stream or batch. Batch means it will be in the form of files or the text files or anything. Stream means it will be in the form of zeros and ones or the binary data, where we can able to make it as a real time. For example, there will a real time applications. We are now streaming the video, correct? We are not storing into files, we are directly converting that in the form of streams, which will be zeros and ones in the live. This will be converted into, and that will be showing this is live streaming. Now if I'm going in the vehicle, there is a driver or there are the people where the live webcam and the live dashboard and the live images will be get in the form of stream, and the historical data will be stored in the form of batch, which will be in the form of files, and that will be stored forever till we use it. The learning approaches will be online and offline. Offline will be the periodic updates, which will be like it will be it will be not online, but it will be given or input by some other people who are managing the strategy. Online means continuously whatever the data that is coming in, as far as the cognitive learning or image optimization or image or natural language processing, it will trying to understand, it will be going forward with that particular data which is online, on the go it will learn. Means learning means reinforcement algorithms. We have supervised, unsupervised, we have, there are many algorithms, we no need to go deep, but based on the algorithm type, it will be having trial and error method. And one algorithm, it will understand the previous data and the past predictions, it will do with the probability and statistics algorithms, correct? Now when comes to AI devices that is in the vehicles, right, it should be able to take the quick decisions, otherwise that will be a disaster. That quick decisions will be there clearly, otherwise it will become disaster. Disasters we no need to encourage, even that will be having minimum or maximum latency time, which will be turnaround time, how much time it is taking and all. We need to enhance privacy and security, because say without security, hackers will come and interpret the data, and they can able to modify the data, binary data, so that will become a great threat. So cyber security and offline capability will be there. Offline capability means if there is a places we are going to rural areas, there might be less internet connection or there might be unstable internet. It can able to store the data in the offline, or whenever that is connected back to online, it might be able to switch back to the online and can able to get the latest data. They need to download the offline data. Even for example, this offline mechanism, in olden days we have Windows systems, Windows Microsoft standard, correct? This Microsoft standard Windows systems are offline capable. That is where most of the Windows .NET standard is using in olden days. Because in the ships or submarines, there will be a technology offline data should be there. Whenever they came online, they can able to switch the real time again. Till that they can able to store offline. For example, I added one user in the database. It will be storing in offline in your system itself, and it will be routing to online whenever that is switch back to online. Correct. If I see how we are there in the online also, there will be a technique. There will be technique in all the programming languages. If I give one technique, correct, go to browser, we can able to check whether we are online or not. That capability there in every technology. So there is a navigator API. Navigator, I will zoom it, I will clear it. Okay, navigator dot online, true. If I disconnect the internet, so navigator is the API, correct, in the browser, which will be JavaScript. So it is having everything. For example, we have geolocation, correct? Geolocation dot, I think small g, correct? uh, navigator dot geolocation dot get current position. So I have the callback method, which is get current position. Here I have the callback method, so that I will do console log, let it be, correct, x. So it will be getting the coordinates, which is will be timestamp. So this timestamp will be seconds. We can able to convert the timestamps to date. It will be automatically convert. This timestamp will be multiplied with 1000, then it will be converted into date, correct? So this will be timestamp. If I do this right, uh, where we are here, so here it is the location. Okay, let it be. I will do one more time. Timestamp, the current timestamp, because timestamp is unique. Timestamp is unique. This coordinates, latitude is 12 point, longitude is 71 seconds. Sorry for that. Yeah, latitude and longitude will be able to get that. So if we are getting new date in the form of seconds, see, it is getting February. I think I given wrong. 1 second. I will remove this. Yes, it is getting October 15, 1907 GMT Greenwich Meridian time plus 5:30 means universal time. We are adding 5:30 hours to make it Indian Standard Time. Otherwise, it will be in the middle of the globe, which will be around England some time and all, Europe time. So it will be zero, correct? So this timestamp we are converting to date. That is the uniqueness. So everywhere, if you are seeing somewhere, right, every programming language will able to make the real time updates along with the timestamps also. So that will be continuously there for any real time system, whether from online to offline capability, for all the system from JavaScript to C Sharp, Python, Ruby on Rails, Swift, Kotlin for Android development. Everything will have this capability to check online or offline, to check the location, to check the dates. Everything inbuilt functions are already there. So we use that and make it possibility of online or offline. When it comes to online, we'll connect back, we'll be checking continuously. Navigator dot is online is true or false. These boolean conditions will be checking always. Now the infrastructure, how we can able to maintain, this is very important concept in IT perspective, so that students also can understand when we explain it. So the first thing is vehicle sensor. There will be a team or the engineering team where they can able to maintain the sensors, whether it is damaged or new. new parts we need to replace, that will connect with some of the data sources. For example, vehicle telemetrics, weather systems, GPS data will be communicated with some cloud storages. That cloud storage will be able to process this much large data using some processing mechanism. For example, now 140 crore people, Indian people, doing transactions at same time in phone pay. How it is processing? Because of Kafka, RabbitMQ, Azure Service Bus, AWS Kinesis, Apache Nifi. Among these, the most important one, the most famous one is Apache Kafka, or Azure Service Bus nowadays, or AWS Kinesis nowadays. So now it will maintain the queue, maintain first in first out. Queue is the data structure, we know, first in first out, it will maintain. So now here the jobs will be raised for hardware engineers, where the site reliability for maintaining these cloud storages, correct, and data sources. Here vehicle assembling hardware engineers who are able to connect multiple devices and all, understanding their internal architecture, those people, and those people who are making the devices like sensors and all, which will be embedded VLSI, those jobs will be created enormously, because AI and data transformation will happen with the help of hardware devices and smart AI enabled chips. So that's where, when comes to mining, for mining people, silicon related powders and related plates, manufacturing industry, sorry, not manufacturing, mining industry will be raised like anything. Again, from mining, that is one thing. From comes to production, manufacturing 3 nm chips, 7 nm chips, I don't think 7 mm, I don't know, 3 nm and 5 nm, I know, nanometers, right? So this manufacturing will be more important for precision of the data, data injection and all, because this will be transferred securely. So these jobs will be created enormously now. Again, now data ingestion wise, there are many jobs where the data processing will be there from multiple devices, correct, from multiple devices. So there are data engineers requirement will be there, data engineers who can able to understand cloud, and using some machine learning algorithms, they can able to process data into multiple forms. From receiving cloud, they can able to understand AWS, GCP and all. From there, they need to query the database using SQL, so that they can able to get the data and able to transform from MongoDB to SQL, which will be RDBMS, again RDBMS to NoSQL, which is MongoDB, and processing the data to Kafka streaming API and everything into multiple, whatever the, technology that we are using. For example, Google will use GCP related, Azure Service Bus, which is another, which is alternate to Kafka. Kafka is by Apache. Again, Azure will be used by Microsoft related stack, which is .NET Core Web API, which is .NET Full Stack applications, correct. And storage, how we are able to store, the way we are storing in the cloud or DB with the time series analysis of the data. So this site reliability engineers jobs will come here again. And processing engines, Hadoop, Flink, Apache Spark, this is the data core data engineer, how we can able to process the data. For example, when I was working with Siemens, there will be a continuous data that is coming from MRI scan, CT scan missions from the back office, so that there will be multiple claims that we are injected for all the hospitals, which is a monopoly. Siemens is the monopoly for MRI and CT scan missions. We already know few of them, which we already went to hospitals for our things, right? So it is having the multiple data that will be in the multiple forms, that will be in the scanning report, that will be in the PDF, that will be in the data prescriptions, that will be stored in multiple formats. So that multiple data along with the real time data, the video that is transforming now currently, which is streaming, everything will be processed in a similar fashion, so that in the outer end we can able to process it. These data engineers can able to process. There will be a job who is having Apache Spark and Hadoop. Hadoop big data, we already know. In big data in the fourth semester, I think eighth semester or something, big data concepts also there in our computer science background people. So we're just not giving PPT on Hadoop at the time. I also given PPT on big data when I'm in I think third year, before fourth year itself. So the thing is, they just explained Hadoop, veracity, velocity, and everything, and I just finished the PPT and all. The thing is here, there will be a large amount of data will be processed. Now big data engineers are huge in demand, and now All, if I combine this, data engineers and machine learning engineers will also be required. But it is not like application development, full stack application development is gone. No, it is the number one job, then only the next people will come. So if I am using lightweight applications, then there is no processing of Kafka, then there is no processing of big data Apache Spark. If I'm using lightweight application, then no need. If I'm using larger applications, that's where these roles will be into more MNCs and the more hospitality, healthcare, and insurance industry along with banking. Otherwise, these roles will not be created. These roles will be created for the multinational companies which is having large amount of data daily, which need to process it by the help of the engineers, where there is the job for that. And the governance will help with location security, data security, which will be like cyber security engineers, right, along with their particular white hat hackers and the black red hat hackers. There will be multiple people who are protecting the systems every day. So if you don't if you surprise that every day there will be a, like every day there will be monitoring will happen, where whenever the fresher job, whenever someone, someone will join, right, in a company like Tech Mahindra, TCS, Infosys, Wipro, Capgemini, Accenture, Cognizant, uh, TCS, which I mentioned, Wipro, anything. These type of companies will show for the US or US based, UK based, and Australia based companies most of the thing. But government projects, what I see, Indian government HCR is maintaining Aadhaar application, IRCTC is maintained by TCS, and income tax is also maintained by TCS. So few of the applications are Infosys. Now few of the government websites are maintaining, which is the Indian multinational companies. So they are doing this, but along with that they will be supporting these applications daily. They are not developing it daily, they are already developed. There are the people who are maintaining. So in the perspective of security, there are cyber security engineers who are already hacking it. Because of that, so if you are in a room, right, you will lock the door by going inside, but the outer people cannot unlock it till you unlock. That is where internal hacking team will do, make it as ethical hacking. So security will comes here, so that cyber security engineers jobs will be increasing 100x in the next 5 years, because everything is transforming to AI. If someone disturb the data silently, then everything will be collapsed overnight. For example, if I say Goldman Sachs or the Morgan Stanley or the Intuit or anything, the world's largest bank, American Express or anything, which are financial institutions, I can say in the foreign, trading perspective, these people, if something is happened, the next day they will collapse. But that is a large empire. So if you see, previously there is a cyber threat happened because of some other update in the security for the Microsoft Windows is blackout. So one day, so it's almost not one day, but it might be some hours. The aircraft control, everything is stopped. They issued offline tickets. So this type of blackouts will be there many times in the future because of data governance and security will be take care. These jobs will also created enormously. Now in transportation, from infrastructure, I can say infrastructure perspective, there are many data centers to be established. So now one of the data centers we are seeing in our, with our eyes in Vizag, that is coming based on that public demand, like public transport, how it is going to transfer. So there are electric vehicles that are coming. For those electric vehicles in upcoming days, there are the streets or there are the roads. In the below, there are magnetic force which can able to transfer the energy. That will also come along with sensor detection and real time tracking. So for logistics there will be an applications in future. For example, DHL introduced an application. So you queried an mobile phone to your cousin who is there in Bangalore from Hyderabad. So now I will be getting real notifications even though I don't ask it. I will just install that particular application. I will just bookmark that particular, order of transit which is in transit. Then every 6 hours, if I put an alert, it will automatically come along with latitude and longitude, and it will be raw data. Latitude and longitude will be raw data, but where the exact location with that particular Jeep image for real-time tracking will be the information. The raw data will store the data in the form of anything, but if you display that in a representation format, that will become the information, as we know. So that this will be increasing a lot this way. By they will introduce more and more apps now in the upcoming days as a part of AI. Image optimization, now EPFO 3.0 is coming. Now Aadhaar also is updating. So now we no need to go to Seva centers and all or any other place, but they will be having face recognition model. Our India is trying to introduce that. Face recognition model will be there for any app. With that, they can able to understand you, and they will be sending the other authentication OTP. So then immediately we can able to change the address or the name corrections or the date of birth something. But again, for date of birth, there might be valid proof we need to upload. It will auto approve, or it might be approved for the admins. So we no need to do this. Simplest process will be happen in the healthcare industry, in the government, and also along with transportation. So now infrastructure wise, there will be many data centers which will be storing multiple data in upcoming days. The data centers alone will reach 100x in the surge. So now, if the data centers are increased, that is the one of the example. Google is coming here. Now, if data centers are increased, what are the jobs that are coming? We will get infrastructure engineers, site reliability engineers, network engineers, everything. You got my point. So that is where it will be introduced. So if we see the real-time monitoring, as we discussed, location tracking, how it will be maintained, the speed, and early detection of faulting, and also it will be reducing emissions because we'll do on time services. So this and all will be there with the help of sensors, and it is sending to the data to the admin dashboards who are maintaining that particular vehicles as a manager, store manager or something. They will able to analyze it, and they can able to improve the man-made things. But there will be no loss of jobs, but there are new jobs that is created to maintain all these activities. AI will not take over the jobs, but it will give the jobs in an alternate way, who is having effective behavior to maintain this. So, which will help us cost reduction. A route is also optimized based on the weather and date and time and the previous data. So, delivery time prediction will be accurate based on the algorithm. That algorithm will predict the time, sense, and everything. And how to utilize this on time. So this transportation, for example, if I implement this way, this will be included with sensors, and that will be included with roads, trains, and all. Everything will be included with sensors, so that they will send the data in real time. And also based on that, automated vehicles also will come. This already started anyway. Automated vehicles from Tesla to started, because these algorithms will run based on the object detection, based on that whether it move to left or right, whether it will become slow or fast before it is approaching 100 meters. It will be changing its strategy. So that will be continuous improvement based on the algorithms, correct? So that is where from hardware to software, everyone will be involved to build this particular system. So when comes to ethicals, right, there will be more risks for security and safety. We need to maintain the transparency and autonomous body, so which will be decentralized. So now in future, it will come as Web 3.0. Web 3.0 should come as early as possible to make it transform, because Web 3.0 will be decentralized. Bitcoin is decentralized, right? From Bitcoin, we know Web 3.0, which is a blockchain. This blockchain will help us security risk and data governance concerns, which will be able to maintain and see by each and every individual who are involved in that chain. So nothing will happen apart from that. Even we have a smart contract copy with everyone who are involved in that particular peer-to-peer network, P2P network, what we will call, as we already seen that in the blockchain technology. So that will be implemented so that we can able to maintain a we will able to transform it in transparency way by reducing the risks. Challenges, I can say, for rural areas and for the infrastructure issues, there will be major, challenging thing. And also talent, whether everyone is learning perfectly nowadays. The intelligence got decreased for the generation to generation. Now it is Gen Z. Now the Gen Z is having patience or not, whether they are focusing on real skills or not, right? So that is also one of the issue. So we want to shift. For example, yesterday itself, I created one institution. which is the normal. The next month AI will come. With that, how we want to change? Sorry. So this and all, shifting and scaling due to the demand will also be changed, and quality. So in rural areas there might be less, less infrastructure or less, internet that might be having the gap to fulfill that data. That is one of the risks. So how we can able to maintain even the villages? That might be somewhat difficult. There we want to switch to offline transport, like offline, that will be converted back. So these issues also will be there many to do this transformation. But it is for cities that might be there easily they can transform, but with these challenges. So at the end, what I say, there will be a huge change that is happening in the next two years, because there are many startups are implementing these solutions background, along with many companies like KPIT technologies to till many semiconductor industries or VLSI industries are trying to implement this, so that they can able to start this production with AI enabled chips and all. And even Nvidia graphics also implementing more GPUs and all, that will be there, we are using it. So now in future there might be a possibility that this transformation will take some 5 to 10 years in India, slow and steadily, because this will be also cost effective. This will also, we need to invest it. Now the AI is hype. All the AI agentic AI is failing now, because if you give 10 inputs for that, from the first to second input it will do reverse. Whatever the input that it is doing reverse. Even there is a scenario, one of the AI is not switch off, right? In China there is something happened, AI beat one of the person. In China there is a something happened. Few of the AI robots talk to each other and went out. There are many scenarios we need to take out and we need to risk it. But when comes to jobs perspective, semiconductors industry, VLS industry will be scale up like anything to 100x. In India we are manufacturing now, we are exporting, we already did our first export this year, we already did. And software thing we can know, AI and ML engineers along with data science engineers and full stack developers. There is no less opportunities for full stack developer. There is a huge demand for full stack, because there is 10 is to 1 ratio for the AI and full stack developers. Because if I'm developing an application, I want 10 engineers, but AI and ML engineers I want only one or two. Remember this point. Definitely this is the case. Apart from the site reliability engineers, SRE role is very huge, because data centers, data storage maintenance, networking traffic, everything, site reliability engineers, cloud engineers, and networking engineers and cyber security engineers will be the huge demand in upcoming days. Correct. So these are the possibilities of the jobs also, so that when someone asks us, so that we can able to guide them properly. And also before going out of the college, they might be in a scenario like they want to implement any application with their own knowledge. Otherwise they will not at all get the job. That is very important. So nowadays the people are just learning and keeping it aside with the basic concepts like oops and all, but that is not the case now. They want to implement a design pattern in live. They want to implement a HTML page in live, which will be like with some images like on the spot. In olden days we're just answering the questions, but nowadays we're just writing the implementation for that particular scenario. This is how industry transformed from 2021. Before 2021 is a normal only, because from 2021 that level of difficulty has changed in the examination or the entrance exams in any program, because everyone is doing online, right? Online means we cannot see the person physically what they exactly doing. So that's where it's increased, and again this will increase a lot because of the competition and the demand with respect to the outcome, how
Sir?
many people. Yeah.
Excuse me, sir. Yeah. Thank you so much for
Yeah.
all your wisdom, sir. But, we will
Yeah,
have
so
to
I
move
just
on to.
concluded, madam. Thank you so much for this opportunity. So in the given time, so I hope I don't bore you at all.
Not at all, sir. Thank you so much.
Yes. Thank you. Thank you, everyone. Teaching and
Yeah.
non-teaching faculty, HODs, and head of the departments for giving me this opportunity.
Thank you, sir. And to everyone, I would like to let you know that there will we will be moving forward without an allotted break, and we will be moving forward with our next session for the day, which will be about IoT integration and intelligent systems, which will be taken over by Mr. Kotresh. We have already talked, sir has already given a talk previously on the first day, and he will be taking over today as well. So, stage is all yours, sir.
Yes, good evening to everyone. Am I audible?
Yes, sir.
So, shall we start with the presentation or any kind of waiting is there? Is just now
None,
one
sir.
more,
None, sir.
previously one more session is finished right just now?
Yes, sir.
Okay. Yes, good evening to everyone. So, as I got a information, like I got a same participants. So in the last sessions, we discussed about the IOV. So the challenges with respect to the internet, how well we can implement IOV in real-time environment with respect to the automobiles, with respect to home automation, like with respect to the industry automation, everything we discussed. So now we have a presentation session on integrating IOV and mobility as a service for future urban mobility, a smart and sustainable transportation framework. So as you know, we already discussed how well we can utilize the IOV, like Internet of Vehicle. So Internet of Things for a vehicle, actually it is a nothing but, so things are nothing but a vehicle here. So we already discussed about that in the previous session. So including all this concept, finally it is considered as a ITS, Intelligent Transportation System, right? So including whatever we discussed last time, and of course, we call a word called a smart embed system, smart automation, smart traffic light or smart TV, because something intelligence is added to that, right? So that's the reason whenever we are integrating these kind of facilities for an existing transportation system, we can give a word, the add-on word called as an intelligent transportation system, integrate communication, computation, and control for a smart mobility. So the purpose of this one, of course, as I already mentioned in the last class, so there is a purpose for every technology. So technology is implemented because there is a requirement, right? So let's see, The purpose of this ITS, especially intelligent traffic system, is especially to improve the safety, efficiency, and sustainability of the transportation networks. Okay, so already we have a good ITS for air transportation, because we have a very good system like the aeroplanes. I mean, air traffic means aeroplanes, and like jet planes. For all these things, already ITS is already there. Because of that reason only, even though, because like even though the plane is not visible to the another plane, but still they can able to detect, because it is already having such kind of system. And as you know, like it is not like our road network, road transportation media, where the road is visible for us, the for eyesight. But when it comes to the like a transportation system like air transportation, the things are really difficult to identify. And controlling, as you know, like compared to vehicle speed, like air traffic elements end device speed will be way more. So during that time, these kind of ITS system is already protecting them. Okay, now we are trying to implement same kind of ITS system, same kind of IT, by combining the IOB plus mass mobility as a service. By combining both, we'd like to make it like a ITS, existing transportation system, as an intelligent traffic transportation system. So ITS forms the backbone of the future smart cities by reducing the congestion and enhancing the energy use. So of course, when we make all the vehicles connected to each other, and the things are able to communicate to each other based on the requirement. And when we are able to see that when there is a uh, like uh, there is a possibility for everyone to connect to each other through the through the internet. Everyone means vehicle I am talking about. So when the vehicle is able to connect it to each other vehicle through some particular system, so due to that reason, of course, it has its own benefit, right? So the accident will any kind of the information broadcasting is required, means it can be done easily because of the network establishment. So goals of the ITS in a smart cities: reduce travel time and accidents. Of course, when uh, like already we have a one small mini intelligence system is already there. That is a GPS, like a Google GPS. Because of that reason, we are already able to know where exactly traffic is more or less, and is there any road breaks. All those information is already there. Still, it is not that much accurate, but still it is a kind of the smart traffic management system already available. Same way, when we, instead of just individual access of the network, so if we make all the cars, all the automobiles in a one particular network, it will increase the safety a little bit more, enhance fuel efficiency and minimize the emissions, support autonomous and connected vehicles, so improve overall quality of the life through the smart mobility. So let's see what you mean by mass. So mobility as a service is a digital platform based approach that integrates various modes of the transportation, such as public transit, ride sharing, bike sharing, car rentals, taxis, and even more micro mobility like e-scooters into a single user-friendly service. So actually, recently I visited one of the hackathon. In that one, there was a one proposal by the group of students, because it's really good whenever we have a group of students who are having the uh, like uh, uh, the space for innovation, because their minds will not be having burden of earning at this moment. Due to that reason, they can come up with a really wonderful idea. So what idea we got during that particular like during that particular hackathon was like, instead of the buses predicting, saying that okay, number of users for a certain area A, area B, area C, and area C. So they predict in that number of users for area A will be more. That's the reason they are going to release so many buses for that particular area. But sometime what happens due to the events, or maybe due to the holidays, or maybe due to any some reasons, if the number of users are reduced for that particular route, or if the number of users are increased for a certain route, during that time, so if the systems are not connected over the network, it is very difficult for the public transportation medium, especially like in Bangalore we have BMTC, APSRTC, anything you take. So they want a one particular demand on demand service. Example, in a very simple on demand service, if I am having a more number of visitors waiting in a certain area slot, so it's nothing but how we have a platform in train and the central bus stand. So if we have any kind of digital platform where whenever the people are going and standing in front of the bus stand, they should be able to register the interest towards which route they are having the interest now. So they like, I would like to go for a route A, I would like to go for a route B, I would like to go for a route C, like that. So these options, if we provide to the users, so what the user will do, they will try to select the required route, which route they would like to go in that particular duration. And that information, if it is connected to the vehicle, that means vehicle management systems is already present. So we can get an idea of how many users are waiting for route C, how frequently I had to send the buses, or how frequently I had to drive towards that particular route. With respect to the public transportation, I'm talking about. So that has its own benefit. It is going to reduce the unnecessarily only for a 30% efficiency. That means 30% of the seating capacity of the entire seating capacity is filled, and even right. So you can't tell that when only 10 members are there in the get down. We can't like public domain. So if we can connect the demand the chains over internet with, so they can show the interest whether they want to go for a. So at that time, what happens? Many things are going to change. So like that, right? Example, say that when now it is not compulsory, I should always go. I have to show that I have to post my requirement particular ABC area. So I with the multiple users, the user can show the interest whether they want to go for A or B. So at that time, what happens? Many things are going to change. So like that, right sharing Hello, am I audible now? I got information saying that there is some issue with the voice. How about now?
Yes, sir. Now is audible, sir.
Okay, okay. Yeah, so we were discussing about the mass, so the mobility as a service. So how well it can helpful for the user to connect each other and get the benefit of it. So core technologies in IT is the vehicle add-on, ad hoc network, VNets, intelligent traffic lights, virtual traffic lights, mobility prediction system, communication technologies like a 5G, DSRC, and low latency networks. So these are the Yes, am I audible now?
Yes, sir.
Yeah. So we were discussing about the let's discuss about the vehicle ad hoc networks. So enable the vehicle to vehicle communication as well as the vehicle to infrastructure communication. And vehicle ad hoc network is also helpful for us to have a real time data exchange between the data exchange like a speed, location, hazard data, support a route optimization and emergency alerts. So let's discuss about each and every the factors in deep. What exactly we are going to get a benefit in V2V and V2I communication. So of course, V2V communication in the last time presentation also I said whenever there is any feasibility, any kind of facility which is available, the cars can reduce their beam intensity as soon we have a requirement. As soon two cars are coming in front of each other, it should be able to reduce the beam. So user no need to worry, like both the users are not like beam light should not be in the control of users, so it should be control of some systems. So such kind of feasibility is possible only when there is any kind of communication between the two ends, right? So V2V communication allows the vehicle to wirelessly share the data with each other, typically using the dedicated short range communications, DSRC, cellular V2X, CV2X, and or 5G networks. So it's something like short range communication, like whenever both the devices are getting any kind of signal from the similar kind of frequency or similar short range communication is able to establish between the two vehicles. So during that time, if they are able to exchange the data, it will be really good. So each vehicle acts as a smart node in a dynamic and ad hoc network and continuously transmitting and receiving the information. So it is a smart node, sorry. Like each vehicle acts as a smart node like in a dynamic way and ad hoc network and continuously transmitting and receiving the information. It means, example, like if I am getting a one vehicle which is coming in front of me, as soon the any kind of requirement of sharing the information, I'm going to share it. As soon the vehicle is passed, again I will be waiting for the next vehicle or next public transport system to get receive the information and transmit the information. Such kind of things are going to work. Data exchange includes speed and acceleration, direction of travel, brake status, position via GPS, hazard warnings, slippery road, sudden braking, collision head, like this. All this information we can provide the info, like we can exchange these kind of information from one vehicle to another vehicle. So because whenever the vehicle has any kind of system which can automatically detect the based on the experience whatever vehicle is able to observe through the camera or through the braking system or through the driving experience. So instead of user giving the sign to the in opposite vehicle, so nowadays already we have that human to human, driver to driver communication is happening in many cases, where one driver is going to give the communication he's going to communicate with the other driver and going to give the information. This is what happened in the like ahead there is a such kind of issue is there, or like this is what the problem that we faced through some hand signal or through some way we are communicating already, but it is not a completely accurate as well as appropriate. But when the same thing we are able to do with respect to the V2V communication, that is really great, because you no need to worry whether like sometimes even the user is busy in the driving, or user is busy in some work where they are not able to give a information to the the person who is coming in front of the vehicle which is coming in front of that particular user. But when we make it like a vehicle to vehicle communication, it will become a totally like a closed loop system where both the vehicles are going to communicate to each other based on that requirement. So that can be done over the short range communication also, that can be done over the 5G networks, that means through the internet also. So benefits: prevents the accidents by issuing the collision and lane change warnings, improves the roadside safety through the coordinated driving, example platooning, and enables smoother traffic flow by synchronizing movements between the vehicles. So we know, right? Most of the times, what happens these public domain works, it will delay, it will not happen on time, and there will not be any kind of information. Like last time when we traveled in that particular road, there will not be any kind of road closure or road work is going on. But whenever we are traveling the next time, there is a chance. But sometime what happens, they like, of course, most of the cases as I observed, so they may give a small warning symbol or small kind of symbol which is just a 10-meter or 20-meter distance from the vehicle, saying that road closure, take a diversion, or road work is going on. So that is also one of the benefits which is there in the vehicle to vehicle communication.
Good evening, sir. Hello. Sir, good evening, sir.
So sorry, there was a small call. So due to that reason, what happens, like whenever we have these kind of the communication establishment, so what happens, it is going to give a lot of benefits with respect to the preventing accidents, right? So real-time exchange of the speed, location, and hazard data. Of course, it is also coming under the V2I or V2 or V2V communication. So vehicle broadcast the basic safety messages, BSMs, every few milliseconds. The network aggregates these signals in real time through the edge or cloud servers. So system detect the anomalies such as sudden braking, stalled vehicles, and conjunction. So that is also most important, because whenever there is any kind of issues happening, even we observed in many cases, especially we saw some reels where due to the fog, vehicles are colliding each other without any kind of control. Because as soon there is a fog, what happens, like we will not come to know what is there ahead, right? And in the highway, what happens when the vehicles are moving in a very high speed, if one vehicle hit and stop, so another vehicle, definitely it will go as a serious accidents, right? Series of accidents is going to happen. But if any kind of system which is present, see, we have a collision detection, we have a anti ABS, everything is there. But then also when the like we have a very less time for that action. Whenever we have very less time for that action to react for the issue, so whenever there is a short distance, accident is the only thing going to happen. So due to that reason, always it is better if you go with the concept of reducing these factors by connecting the vehicles to each other. So applications, of course, many applications are there. Hazard alerts, dynamic speed control. Like last time, as I mentioned, whenever there is a vehicle which is in the particular speed zone, so it should be able to dynamically control its speed. No need to wait for any police or any person to like um, monitor the vehicles, right? Geofencing and dynamic tolling, where authorities manage the traffic zone intelligently. So these things are there, like with respect to the I2 V communication, right? Support route optimization and emergency alerts. With respect to the real-time data from the vehicle and infrastructure, navigation can calculate the optimal routes based on the current traffic incidents and weather, right? So this is already, it's there in the, even in the Google also. Google Maps is doing this. So where it is going to give us the alternative route by telling that 5 minutes will be saved if you go within a particular route, and you can save the time, and the traffic is also less in that particular route, like that, right? So mass platforms can recommended multimodal alternatives, so switch to metro or shared ride if the road are congested. So now it is not available yet. So if the traffic is too heavy, so being a user, we only like, let me consider I am getting a ride in a particular public transport, or maybe in the the driver who is driving, there is a separate driver for that particular car example. So being a passenger who is sitting next to that, so what happens now, I need any kind of suggestion by the system. So now the traffic is very huge, it's around 100-meter traffic is there ahead. So better you can take a metro, you can take up some other transport which is nearby, just 50 meter away from you. So you can take that transport to reach your destination as early as possible. So such kind of things also we can provide. So this leads to travel reducing in travel time, fuel saving, and lower emissions. Then emergency alerts and response. So when an accident or medical emergency occurs, the vehicle automatically sends the emergency message e-call to the nearby vehicles and control center. So here what happens, like whenever there is a any kind of like accidents or any issues happen, so instead of someone wake up and the call the ambulance, sometimes it is not at all possible because accident might be severe and nobody is conscious. Due to that reason, if the vehicle is a one more person who is next to us indirectly, so if that is able to detect and send the information to the over the IOV, it will be really good. And it can also send the information to the IOs, the infrastructure which is nearby. So that also is going to helpful for us to solve that, manage that particular emergency situation. Traffic lights along the route to the hospitals or rescue sites, that can be primitively controlled to create a green corridors for the ambulances. Of course, this is in many cities they already implemented. And whenever the ambulance is coming in a certain route, so sometimes automatically it will detect. Sometimes police is going to trigger the signal. But unfortunately, what happens? It can trigger only one stage signal, because traffic light will not come to know how exactly vehicle is planned to move. Understood. So whether the vehicle is going in a straight direction, left direction, that will not be recognized by the all the traffic light which is present in that route. So if we can make a one particular setup where the vehicle as well as the traffic lights both are connected over a network. If I tell X, I would like to go to, there is an ambulance, and ambulance will have a ID, everything. And if the ambulance is registered itself, yes, I would like to go to this particular route. Okay, so as soon the vehicle is approaching towards the traffic area, that means towards that particular traffic light area, traffic light signal, so it's supposed to turn on the green by itself. Not only one particular light, all the lights which are present in that route should be able to coordinate by itself without any kind of manual control. Then intelligent traffic light systems. So of course, the previous slide only I explained a little bit about that. So use sensors and AI to adopt the signal timings based on the live traffic density, reduced idling and fuel consumption, and enhance the pedestrian and vehicle safety in at it intersections. So generally, how exactly the sensors are going to work, already you would have already experienced many of the density based vehicle traffic light control. So sensors and IoT devices inductive loop detectors, cameras, radar, lidar, and infrared counters. These are all embedded at its intersection to monitor the real-time traffic flow. So instead of blindly turning on the green light for 30 seconds, like 90 seconds, so instead of that one, turn on the light based on the traffic density, the minimum the maximum duration we can cut it off based on the requirement, right? So these things are already implemented, and whenever we make it like over the internet of things connected with this particular like existing setup, it will become more robust. It means not only because of the local not only because of just a one lane traffic, so it is going to calculate all the traffic signals, like all the densities at the different traffic signals, and it is going to make sure that all the traffic signals are going to connect it to one particular network, and which is going to finally make sure that instead of only making a one light 90%, so it can distribute the traffic by controlling the traffic flow in the multiple stages of the same route. Okay, so that is possible when all the traffic lights are connected to each other, right? So that is ITL, intelligent traffic lights. And AI algorithm analyze this live video data to dynamically adjust the green and red light durations for each second. And system continuously learns the traffic pattern, rush hours, weekends, events, using machine learning models and improving the timing decisions over the time. Of course, this is not. I think this is not implemented as at this moment, because what happens, like we know, like cities, especially urban cities. So there is a certain period where the traffic will be huge because of the more number of visitors, more number of people are going to rush towards that particular area. So in such cases, it is easy if we have a AI based intelligent traffic system. And of course, if I implemented intelligent traffic system, only intelligent traffic light only for one pole, that pole can be intelligent. But that pole will not have any information whether the previous pole was also like that traffic, having the traffic density, and next pole what it's supposed to, how it has to help the next congestion area to get a less traffic. Okay, so if all are connected to each other, we can make a smart system where I can divide that particular conjunction according to the like flow, and it can also learn over the days, over the months. Okay, then reducing the idling and fuel consumption. So the problem is traditional traffic light follow fixed timing cycles, even though if no vehicles are waiting, leading to unnecessary idling, wasted fuel, and increased emissions. So this is there, like because now what happened in most of the cities, there are AI cameras. So AI cameras is especially waiting for to find out our mistakes, right? As you know. So even though nobody is there in the queue, nobody is there in the road, if the red color light is there, if I am not stopping the vehicles, there is a chance where I may get a penalty by crossing that particular signal, because AI cameras are there. Like camera is there for to capture our mistake. Purpose of traffic light is to maintain the traffic, to manage the traffic properly. When there is no traffic, then also the red light duration is same, green light duration is same, is then ultimately it's a waste of fuel. And of course, whenever the vehicle is in ideal position, it also creates the emissions as well as a waste of fuel. Okay, by sensing, if we are going for a AI driven solution for this, by sensing when the lanes are empty or lightly occupied, the system shortens the red light duration and even switches to adopt flashing mode during off peak hours. So it's again the one more benefit of that particular LTS, like intelligent traffic lights, ITS. Okay, then enhance the pedestrian and vehicle safety at intersections. This is very important. What happens, like whenever there is a cross, whenever there is a L mark cut. Okay, what happens, like whenever the pedestrian is trying to move or cross that particular road, and if there is no any kind of connection between the pedestrian, it may be the infrastructure level connectivity, or it may be a smartphone or smartwatch connectivity. Somehow, if the person who is uh, taking a turn in that particular curve, if he is not having any idea what aged person is traveling, like a pedestrian is moving in that particular road, or what is the condition there. So if he is going in a very rush manner, so there is a chance it may create a lot of problems with respect to the real time scenario. So if we have such kind of connectivity between the human smartwatch with the vehicle, or human smartwatch with the local like a pole, and pole to the vehicle, finally vehicle, the person who is traveling in vehicle or the vehicle system should detect that there is a pedestrian who is crossing the road through the zebra lines. So in such cases, these are all factors are going to consider a lot. V2I communication, vehicles approaching the intersections receive real-time alerts, pedestrian crossing the road ahead, signal turning in red in 3 seconds. So during emergencies, the traffic signals can automatically create a priority lanes or green corridors for ambulances and fire trucks. It is the same concept again. So VA nets in the smart cities. Let's see one by one. Facilitate a connected car ecosystem, enable the collision avoidance and cooperative driving. Example: the Japan Smart Way project and Europe's CITC project. Actually, even in our cities also they planned for a separate lane. That means in the same reserved lane. Indirectly, I can tell for public transport they planned for a reserved lanes, but unfortunately it couldn't work well because still there are the people who can, as I said already yesterday, like day before yesterday presentation, if people are not able to follow the rules properly, we should make the vehicle to follow the rules. Indirectly what happens, your car is there, example, if the car is having the ITS, intelligent traffic system, or it may be intelligent transportation system, as well as connected to IV, even though you are trying to drive towards that reserved path, vehicle should not allow you, right? Vehicle should not allow you to drive in that particular path, that particular lane. So indirectly you are getting controlled by, like controlled by the vehicle. What the vehicle will demand is, vehicle control system will demand is, yes, if you follow the basic rules, then only I'll let you to drive in that particular road indirectly. So whenever the vehicle is controlling you, or vehicle is giving some kind of challenges for you, of automatically you will come into the, like we all come into the one particular understanding, yes, I have to follow the traffic rules, then only I can enjoy the luxury of that particular vehicle. Yeah, facilitate connected car ecosystems. The concept is very simple. A connected car ecosystem is a digital network where vehicles, infrastructures, and cloud platforms continuously exchange the information to improve road safety efficiency, as well as the user experience. Okay. Over air software updates, vehicle tracking and fleet management, integration with a smart city infrastructure like a traffic parking, tolling, cloud-based analytics for mobility and optimization. Yes. Whenever we have a car ecosystem, connected car ecosystem (CCE), what happens? Like it is leading to a lot of benefits. So instead of one car is connected to the only one particular system, if it is connected to the network, as I already explained, so it is having its own benefit. So over-air software updates, or it can be vehicle tracking, over-air software updates means, example. Let me. Sorry. Yeah. Over a software updates means, let me consider there is any kind of new rule in the city. Example, in that city there is a new rule. Government is made a separate lane for separate lane for a public transport. So now your car is already manufactured by someone. Okay, some other manufacturer, and already all the safety precautions already loaded in that. But now there is a new update by the government saying that you have to follow this particular rule also. Now how to reach all the existing vehicles? That is a one more challenge, right? If the vehicles are individually configured, individually having its own local processor, so now the challenge is, if it is not in the network, how you are going to distribute that particular new update, or how you are going to broadcast that new update? So whenever vehicle is connected in a network, example our mobile, so we are going to get a new update of application every month, right? WhatsApp, whatever we are having now, after 6 months it will ask us to update. So nobody is coming and installing nobody is asking, like nobody is coming and installing that new version of the app in our mobile separately, right? So we are going to tell the program, like we are going to tell the Android OS, whenever there is a new update and whenever there is a Wi-Fi connection, or if you are okay with the data network connection, just go for update. Okay. So now as soon as it is updated, we have a new feature. So without any kind of burden for the user got the new features. Same thing with can happen even with the vehicle. So if there is any kind, if all the vehicles are connected over the cloud, so that can be done. That can be done over the air software updates, vehicle tracking and fleet management, right? So they're all the benefit with respect to the connected car ecosystem. Yes, VTL virtual traffic lights. Just a minute. VTL, yeah. So replace physical signals with the in-vehicle digital instructions, right? So leverage 5G communication for near insta coordination and improve intersection throughput and reduce the conjunction. Yeah. So what's happening with respect to this particular VTL? We already virtual traffic lights. So it replaces the physical signals with in-vehicle digital instructions. Example, what we can do is like we can go with whenever we have a virtual traffic light systems. So yes, a certain duration I would like to wait for in a particular traffic location. That means the conjunction. So now what's happening? We are able to see that red color light, and we will wait till it becoming yellow and green. Then we'll move ahead. Indirectly, we are getting the information from some other infrastructure which is present in front of that particular physical signal. So we can also go one step ahead where each and every car only will act as a self-sustaining traffic management systems. Self following or self-sustaining, you can mention, where the traffic light can be automatically vehicle only will sense what is the whether the vehicle is in the duration of transport or vehicle is still in the duration of waiting. So vehicle itself is so instead of sending the if instead of turning on the real physical signal, I can send the waiting period message for all the that particular lane, and that waiting period message is going to keep on counting how exactly the physical signal is counting. Like that we can also make a virtual signal, right? Virtual traffic lights, so which is going to get displayed in each and every vehicle. It look like no red color, but still vehicle will be having that information. Yes, now we are in the duration of waiting period because some other vehicles are transporting. And of course, as I said, when the vehicle itself is having a default system where that particular system has to go with the following the traffic rules, user will never be able to violate the rules. He will not never be able to violate the rules because vehicle will not allow him to violate the rules. I sent the vehicle from some network. I sent the information to the vehicle saying that you have to be in the waiting period now. It means even though you user rides the click on the pedal, anything it happens, the vehicle will not allow them to ride, right? Because of course now also we are facing a lot of traffic issue because the vehicles are getting controlled by the users, it not by the technology. So when we make a vehicle to control by the technology, automatically things will come in line. Mobility prediction, so predicts vehicle trajectories to optimize the routing and reduce the congestion, supports emergency vehicle prioritization and traffic balancing, and relies on the historical and real-time data analytics. So this is all about the mobility prediction, it is going to predict whether we can go ahead with the uh, high speed in this particular location or not, because what is a uh, like conjunction area, at what particular duration we can get a more amount of traffic. So all everything is again we're all discussing about the same topics. It's all about like maintaining the traffic, managing the conjunction, and reducing the accidents. In case of emergency accidents, what can be done through the ITS. Machine learning in mobility prediction. So uses models like LSTM and CNN and reinforcement learning, enables the adaptive routing and planning, anomaly detection, and enhances the ITS scalability and reliability. So this is all about the with respect to the like data. If I'm getting an example, if I'm getting the information from the live camera of any particular traffic light, traffic conjunction area, so instead of I take a decision I should not go in that particular route, vehicle should itself can take a decision saying that, or it can guide the user saying that already there is a lot of conjunction in this particular area, so please avoid that particular route, right? Like this kind of like a vehicle management can also be done by using the this particular mobility prediction. And of course, for all these things, we need a AI/ML integration. So along with the gives the establishment, but AI/ML is also going to give us a lot of predictions, accuracy, improvement in the judging factor. Everything is going to improve by the AI/ML, right? So LSTM and CNN, convolution neural network, and reinforcement kind of algorithm we can implement for these things. Communication technologies like dedicated short range communications by using IEEE 802.11p and cellular V2X network and 5G high bandwidth and low latency network. So LoRaWAN, so long range, low power connectivity for IoT sensors. So they're all the like for a short range, like for short range communication, you can use a Bluetooth Wi-Fi, or you can go with a dedicated short range communication, like a specific frequency range only for a traffic signal alerts, only for a traffic management purpose, right? So instead of that one, we can also go for a cellular. Of course, when it comes to the IoT, cellular network itself is a best method because it can helpful for us to connect to the cloud server with a very low cost and easiest manner. So LoRaWAN, long range, low power connectivity for like IoT sensors. So indirectly, I have vehicle and I want a connectivity between the vehicle system with the roadside systems. So it will be keep on changing. It can't stick. So the roadside systems can't bind itself only for one particular vehicle, right? Vehicle will be keep on moving. Example, like generally we use a Bluetooth earphone. So what happens? My Bluetooth earphone is going to communicate, is going to be paired with my particular mobile system. Then mobile system is going to keep on sending the information to the Bluetooth signal. And once one Bluetooth earphone is connected to one mobile, so it will not be able to connect to the one like another one or another two like that. It will not be able to transmit and receive the signal from multiple devices at a time. But we may have a requirement of LoRa like broadcasting sometime. So what happens in the LoRa WAN wide area network? So we are going to broadcast the information to multiple devices in a short range communication, because it can't be done in a long range. If it's done in a long range, what happens? The vehicles which is not required to receive such certain information, because they are that vehicle is not in that particular area, so it is not in that particular route. It Some other vehicle may receive the information and it may judge in a wrong way. That's the reason short range is required in this particular requirement, right? So broadcasting can be done, and without a kind of any kind of token or acknowledgement, we can send and receive the data as early as possible, indirectly making the communication reliable and portable. So 5G roles in ITS, so enable the ultra reliable low latency communications, supports vehicle platooning, remote driving, and smart intersections, and essential for autonomous vehicle ecosystems. So 5G role, of course, we know the purpose of 5G is it's meant for speed, right? So whenever we have a huge amount of information like a video, live video streaming, or any kind of live data from the one car to another car, so we need a high speed communication. At that time, 5G role is going to really helpful in the real time ITS, right? And also, if any traffic light is capturing any kind of accident or potholes or any kind of issues happening in any conjunction, like a network, like a traffic conjunction area, so all other systems has to receive that information, means it is about to send the information in the video or audio at that time. So we need high range, high speed communication. Then only other vehicles can receive the information in a short delay. Because of short delay, what happens? You can avoid the accidents, right? So we discussed all about the with respect to the benefits, but security challenges is also there. Vulnerabilities in V2X networks can lead to the cyber threat. So threat, cyber attacks, jamming, spoofing, and DOS solutions like a blockchain, cryptographic authentication, and trust management. So these are all the solutions. But as I mentioned in the last session, also when we are transmitting the data over the whenever we are transmitting the data over the internet, somebody muted your mic. Yeah. So whenever we have a data transmission in air, there is a threat. Very simple. So in air, whenever we are transmitting the data, there is a threat, and for that we have, for that particular threat issue, we already planned for many different type of solutions and benefits for like all the different types of things already working in that particular area, like a cyber security, blockchain, cyber cryptographic authentication, trust management. So instead of you receive the blind, instead of your vehicle is blindly receiving the information from some other hacker system, it can go with the acknowledgement system acknowledgement, or it can go with a cryptographic authentication to reduce the security threat, right? So of course these are all the security challenges. Any technology you take, it is not so easy when you are implementing a technology in a one particular manner. So and it is going to create a challenge, or it may demand a certain other challenges to be managed, right? And when you are not able to manage all the types of challenges, then it will become a drawback, right? So all these called as a challenges at the beginning time. And reliability and energy efficiency. So neurophysics systems predict the traffic and optimize the resource use. So resource use and integration with the renewable energy grids for the EV charging reduces the operational cost and environmental footprint. So this all type of the vehicles based on the type of the like when we would like to make a ITS, it is more easy with the EV vehicles compared to the regular vehicles, because EV vehicles uh, easily having like EV vehicles have a lot of sensors, as well as the it has a lot of processors on board. Due to that, design implementation of these kind of ITS is easy for EV vehicles, and because of that reason, energy efficiency and the energy grids for EV charging, that also can be implemented. And the status of those things, especially even many times I felt it is we'll be finding in a Google saying that EV charging stations, and we'll push our bike till that point, and as soon we reach there, we came to know that one, that station is not working. So live data is not there, whether the vehicle, because whether that particular station is working or not, is there any issues with that particular station. If this information is also integrated with our particular EV vehicles, and regular vehicles means the fuel stations, refilling fuel stations. So infrastructure wise, the infrastructure communication between the vehicle and infrastructure also really matters a lot. It is not simply it is showing in Google Map the bunk is open, right? The fuel station is open. There is no assurity. Yeah, it is mentioned in the Google, but there is no assurity. Many times we observe out of petrol, they out of fuel. They will mention the board, but Google it not. Google is not showing that. Google will not show that this particular fuel, if it is closed for a long time, and if the owners or users are questioning the, like if owners or users updating the information in the Google Map, then there is a chance where Google Maps can give you the information permanently closed or temporarily closed like this. Whenever we are not having such kind of feedback mechanism, so we will be blindly following the Google Maps, right? So with the ITS we can do that. So environmental benefits is there, of course. Many things are there: decreased emissions, reduction in idling and fuel wastage, supports the transition to electricity and hybrid transport. Right? Like of course, whenever there is a more facilities available, people try to opt the update technology, which is going to lead to the having more flexibility with respect to the transportation, like modern transportation system. Of course, when it comes to the EV, when the number of vehicles, EV vehicles are increased, so automatically emissions also is reduced. And also with the regular existing ICT engine based vehicles, also because of the traffic updates, idling time can be reduced. And as soon the idling time is reduced, because live traffic signals are coming in the vehicle panel, so as the idling time is reduced, it is also going to reduce the emissions. Because of that reason, user also will get a fuel saving, and even nation also will get a fuel saving, right? Many benefits are there, environmental benefits. Automotive manufacturers adopting ITS. So of course already the modern vehicles like a BMW, Audi as well as Volvo, these are all already having these kind of features, uh, only to their network, again as I mentioned, only to their network. So if we can come up with a one particular solution where it is adoptable for regular existing vehicles also, it will be really great. And we can make them as a one particular package, information followed by each and every vehicles connected over a network. People who would like to enter subscribe for that ITS, they have to just plug particular particular USB modem or something to their vehicle, so that when they should become ITS. Okay, at least the information wise, maybe controlling is difficult. So I may not be able to we may not be able to completely modify the existing infrastructure of the vehicle, where auto braking or fuel information. See, I can, like, through add-on I can give the information to the user, but making the vehicle to take that information and dynamic speed adoption, or maybe the traffic rules like management, or following the traffic rules, all these things are also having the dealing with respect to the vehicle, like especially locomotive system. So whenever we are asking vehicle locomotive system or vehicle driving system has to change, it has a lot of challenges. That challenges you already know, that is not so easy also. Yeah, of course, future opportunities whenever we are going for these kind of ITS system implementation. So blockchain for a secure data exchange, edge AI for a faster vehicle decision making, and integration with the renewable energy for and smart grids, expansion of global standards for interoperability. So all these benefits will be their future opportunities. Blockchain sector is going to increase as the number of vehicles which are having the like a requirement of blockchain. Like a blockchain is secured communication network. Whenever we have such requirement, so indirectly it is not a one time developable concept, right? Like whenever the network is increased, the blockchain or these web app, mobile app, or all AIML, these software solutions are going to get struck because more traffic is flowing through to that. So during that time, of course, we have to go with the concept of modifying it in such a way that when we should be able to manage the things as per the requirement, right? So that also open up the lot of jobs in future, what can be done and how it can be engaged. So conclusion and future scope of this entire session is, so IOB and MAS integration will redefine the urban mobility. ITS drives sustainability, safety, and efficiency, as we discussed till now. Collaboration among the industries and government in vital for success, of course. Uh, it it has to be collaborated with both, because whenever I would like to go with the new in EV station establishment, or if I want to go with the new infrastructure establishment, government also should support for that. So I can't go with everything with the private can, with the private support, or like any kind of company support, we can integrate new application, new features in their own products, like vehicles, two wheeler or four wheeler. But I can't any government will not allow this the private company to come and change the traffic light information, which can helpful for their users. It will not allow. So it is a win-win situation. It should both the end has to join each other, then only it is possible, right? That is what the one thing we have to see here. And ITS drives towards sustainability, safety, as well as efficiency. That's what we discussed till now. Like, so many benefits are there, challenges also there. Collaboration among the industries and governments in a vital role for success, that we discussed already. And future mobility is a connected, and autonomous and sustainable. So provided everyone, that's what, like, see why we are facing the challenge with respect to the implementation something new in these countries, especially in the India, like that. See, everybody is not that category. That means everybody is not having that luxury vehicles. If we make something a small adapting concept where, yes, you plug in the model, you can get an information. Again, that is not also 100% successable model, because information is received by the user, but vehicle is not still in under control, right? That is not also not 100% sustainable product. But of course, over a period when the government or anybody take the decision, yes, all the old vehicles has to be renewed to the new technology. At that time, all these things can be implemented. For current existing users or current existing vehicles, it is quite challenging only, because who will follow the rules? The rules already everybody knows. Most of the time we know the rules, but still we will violate the rules because of xyz conditions or requirement. So all these challenges are there. So so this was all about today's sessions, what exactly we planned and how well we can use the IVV and MAS, integrating both for a smart and sustainable transportation framework. So any thoughts on this today's session or any doubts? Yeah, one of the participants they mentioned is the government of India wants to bring the intelligence toll clearance system using the satellite communication. Yeah, that's really good,
Nothing
because
covered.
previously we didn't have any kind of yeah, sorry, any doubts? Yeah, so previously we were not having a concept of fast track, right? We were not having that particular condition. But now when the government is only accepted for that, and they said that one with fast track the price is less. You can that is a RFID based toll collection system. Without fast track, it is going to, you supposed to pay more for that particular toll. Same way, if we implement for satellite transport is good, but challenging point is um again the implementation to the existing facilities. And as we observed, satellite based toll collection needs a satellite based receiver, so that is way a little bit complex compared to the regular RFID based toll collection, whatever we are doing now. RFID based toll collection, so what the user is expecting, they want implementation, they are ready for implementation, but they want it in a low cost. See, like now currently for RFID based implementation, they only charged around 500 rupees for a one tag, or 100 rupees for one tag. So user is okay for that. Many people are questioning that also. See, previously I am paying a money through cash. Now I am paying through the online. But finally rate is same, or it may be very less reduced. But why you are asking me to pay extra for that particular extra tag? And also it became compulsory. That is, many people are questioning that also, why you made compulsory, why fastag is only the compulsory part. But when the government only made it, the slowly questions will reduce. Same way, when we make a satellite based toll collection, that is really good idea. But infrastructure wise, we should have a good receiver point of view. Trans receiver point in every vehicle should be good enough. GPS is already we are having a lot of GPS sensors in most of the vehicles. That is possible, but we should get a permission for implementing such technologies. Yes, any other discussion can we do?
If there are no questions, then I think it is time to conclude the session. So thank you so much, sir, for coming here for a second time and giving us such valuable knowledge. I am sure that everybody else has also benefited from this session. So thank you.
Yeah, sure. Thank you all.
Yes. And I hereby close this session for the day and let us all get back together tomorrow at 6 p.m. Everybody can now leave the meeting. Thank you so much.
Thank you all. Thank you.